Welcome to this unit of Introduction to Environmental Science, Unit 3, Population Challenge. Lecture 8 is over human ecology. Our changing relationship with the environment. You can sort of barely read that, www.worldometersinfo/world population. I checked it out just a few minutes ago, and actually what is the population at the beginning of class today? Let's see if I can get this to work. I think we have about 7,500,000,000? Yeah, 543,000. 43 million, sorry. Million. There's a zero finally. 11,389 people on the planet. Now, that number will probably go up between now and the time class is over with. So, this is a quote from Buckminster Fuller, who was, I guess, a visionary. He had all kinds of ideas and thoughts, and one of those that he was very much known for is this idea that we are actually on a spaceship. This planet is a beautiful one. It took billions of years to develop, and we're not going to get another one. So, how do we take care of it? How do we make the spaceship work? Another thought by a philosopher named Marshall McLuhan. I can't even say that name right. There are no passengers on Spaceship Earth. We are all crew. So what does that really mean for us? Well, if we don't take responsibility for our actions, like the crew of a ship or a boat, who will? The idea is stewardship. Stewardship is what we're looking for here. It's an outline. Look at the human population, human biological evolution, how it's changed. What makes us so good at this growth thing anyway? Human cultural evolution, as we've gone along. Hunting and gathering societies. Hunter-gatherer is what I'm trying to say, but I didn't quite get it on the slide, did I? Agricultural societies. Industrial societies. Those are the ways we've kind of developed over time. And then there's advanced industrial societies. Population, resources, and pollution model. Not so much emphasis on the model, but we're going to look at how human-generated pollutants, feedback loops, and sustainable society, moving beyond where we are now. And then we're going to talk about this important idea of the library learning assignment. This is the lecture assignment that will be due. Well, the final one that we do at the end of the term, but we're going to talk about what it is going to take to get to that point. So, human populations. The most populous country in the world. I could just kind of take a little quiz on that. What is it? Come here. There we go. What is it? Well, of course, it's China. 1.5 billion people by 2025. Right now, there's only 1.2 billion people, so it's got a little ways to go. But the population is actually going to drop by 2050 by 100 million people. I mean, 1.5, 1.4, it's not that much, is it? Yeah, it's a lot of people. So what's going to happen? Success in terms of population control, it's a very, very controversial idea. It cut their birth rate by 1/2. Reduce the average number of children per woman to 1.5 from 5.7 where it was about 50 years ago. Currently it's 2.1. That's a sustainable replacement rate in the United States. Our population growth, we've talked about this before, is exponential. There is no two ways about it. Slow growth, slow and steady from the dawn of human recorded history. Actually, human recorded history starts about right there, not 500,000 years ago, but 10,000 years ago. So about 5 million, that is what we have at the beginning of the agricultural revolution right there 10,000 years ago. Since then, about 10,000 years ago, our population growth has really only been slowed by this bubonic plague, a little weather, some society collapses, those sorts of things. It's particularly marked over the last 60 years. Let's say since about 60 years ago was 1956, and when I'm recording this lecture. So 60 years ago, that's when most of our population growth has happened since then. Tremendous amount. We've gone from about, well, we had a little more than 2.5, 3 billion people on the planet in 1956. Now we have, well, that's 7.4 billion. A lot of growth. So we've seen this before. This is a graphic showing the population in less developed countries, how it's going to increase and change over these next, particularly 40 years, and then how it's not going to change very much in the more developed countries. See that graphic there. So what does this mean? Each of us depends upon the Earth's life support system for our habitat. More of us there are, less the Earth can support. We are not meeting the basic needs of 1.4 billion people on the Earth. That's a hard thing to realize. Though growth rates have fallen, the forecasts are for an additional 1.7 billion. Let me underline that. 2.7, read the slide, 2.7 billion people by 2050, even though we slowed down our growth rates. A great deal. Again, back to the same graphic, the same idea of population growth. Back from the hunter-gatherer times, our population was pretty flat. Black Death, the plague, dropped our population down to about 500,000, and since that time, we're standing right about here right now, about 7.5 billion people in 2015, 2016, 2017, maybe not that much. Recent event, this growth of human population. We've expanded to almost all the climates on the Earth, well, certainly the terrestrial ones. Modern ag has increased our food growth per area. Remember, we talked a little bit about that in a previous lecture. We'll talk more about that in this lecture. The death rates have dropped because we've gotten better at sanitation, better at curing diseases, particularly early childhood types of things. We did a much better job of taking care of children from birth, so that more and more of them are surviving. Healthcare, medicines, all those things have greatly increased. So, growth continues, but is unevenly distributed. Let's look at this. So, China, number 1, India is number 2, 1.3 billion, 1.2 billion. United States, surprisingly to some folks, we are the third most populous nation on the planet at 310 million people. Next is Indonesia, and then after that, Brazil. Now, fast forward 40 years, India has taken over this top spot at 1.7 billion. China has dropped back, as I said in the earlier slide. Well, they haven't dropped back, they've gone up some, but they're projected to hit 1.5 billion in 2025. Population of the United States has increased. We're still maintaining our third place finish here, not shooting for first for sure, but we still have about, well, let's say 1 billion people fewer than China. Then Pakistan, which wasn't even listed in 2010 in the top 5, has snuck in at number 4, and that's growing very rapidly, and it is growing very rapidly. Indonesia has dropped back to 5th most populous, but its population is still increasing. Population growth in developing countries is 15 times faster. 15 times faster, 1.5% per year, relative to the developed world, 0.1% per year. By 2050, 97% of population growth will be in the developing world, in those developing countries. And is there an optimum sustainable population? Well, perhaps not. Okay. Hominids are considered to be humans and their fossil relatives. How did we come to have an upright stance? Well, hominids started out in the forest and the jungles and began to move on to the plains. So why stay upright? Well, it was more efficient for locomotion. It gave us an advantage because then we didn't have to use all fours to get around. Our large brain size facilitated certain features being developed, such as language, manual dexterity. And it dramatically expanded our capacity to alter nature because now all of a sudden we can handle tools. So we've talked about this in the previous lecture. How do we become such a powerful species? Well, there's some traits such as, well, these three human adaptations. Strong opposable thumbs, walking upright, and our complex brain. Those are the three primary ones cited for us becoming such a powerful species. We developed technologies like the wheel or fire. Those sorts of things have allowed us to take over much of the Earth's life support system, certainly in the last 200 years. The good news is that we still have this complex brain, and it may enable us to realize where we're going and perhaps live more sustainably and turn things around a little bit. So let's look at hunter-gatherers. All human societies have impacted the environment from the very beginning. So how much we impacted the environment depends upon our population size, resource demands, how much demands we're putting on resources, really our choice of resources that are going to support us. So hunter-gatherers, for most of human history, that's what we've been for most of our history. If you look at that very long timeline going back 500,000 years ago, for 480,000 or 490,000 of those years, we were hunter-gatherers, and we started agriculture. Members of these societies apparently had a deep reverence for and knowledge of their environment. Well, they had to survive it. Not always environmentally benign. We certainly weren't. We were always impacting the environment. The low population size and primitive technology, we generally, it was sustainable at 5 million people on the earth for a long time. So look at all these various animals here. You've got the classic saber-toothed tiger, you have the mammoth, I don't know why this is so pixelated, but it is, camel, you have the giant mammoth, I can't even tell if that is a sloth or something like that, some sort of a wild horse. All of these organisms used to be a part of North America. We have been nomadic or semi-permanent for a long time, and we benefit from the intelligence and the ability to manipulate tools, which has probably allowed us to drive most of these animals to extinction. We're generally exploitative of those resources that are available to us. Environmental impact is generally small in these cases because we have small populations and low densities. Fire has been used. Fire use was widespread. We probably used a lot more fire in our environmental and our hunting, if you will, than perhaps was naturally around. So we may have caused significant environmental damage and significant environmental change. So this is an interesting website. Actually, it sort of advocates eating a paleo lifestyle, and I don't advocate one way or the other. But it's where I get this this information. The average age of death is not the same as life expectancy, which we've always kind of looked at that way. Not the same. So why do we bring that up? Well, this is a graphic of cavemen numbers. Not sure what those are in. I think those are tens of thousands. And I didn't mean to go on to that next slide. There we go. Let's go back. Yes, number of cavemen. And you can see, if you look at this, that this is when time of death, age at death, a vast majority of these paleo people, if you will, cavemen, did not live to be age 10. When you take the average of that, you can see that there are actually a significant number of them that actually live to age 65 or 70. And this is, 20, 50,000 years ago. So when you say the average age death of a caveman was 25 years, well, that's because you average in all these infants that don't make it to adulthood, and that drives that average down. So that average is not necessarily an average in terms of the actual life expectancy. Life expectancy for these cavemen, if you will, is longer than we would expect because their life expectancy was not the same as their age of death. So we started out developing agriculture. We have these various places that we actually looked, started developing agriculture in Mesoamerica, Andes, various things we developed there. Of course, this is part of the Fertile Crescent, the Indus River, and the Honghu River region in China. So we have 5 different regions around the world where agricultural societies began. And the agricultural revolution kind of all started about 10,000 years ago all across the globe. We domesticated plants and animals, and our populations started to increase, developed cities, and changed our relationship with nature when you start living in cities. We had to cooperation and respect is what we had as cavemen, cave people, if you want to be that politically correct. From going from cooperation and respect to domination and exploitation. That's what we moved towards because we wanted to control things. Our population was going to grow. So, agricultural societies really began 10,000 years ago. Farmers, generally subsistence or some urban-based, even 10,000 years ago, they benefited from these new technologies. New technology at the time was the wheel, the plow, domestication of animals. That was something that was new and certainly allowed us to feed a lot more people. Became much more knowledgeable about domesticated crops and animals. Began to exploit resources a great deal more. And that impact of subsistence farming was actually quite large, and that's what this is considered, subsistence farming. We will have an assignment on Swidden agriculture later in this unit, towards the end of the unit. Population sizes were still small, and so was the density of people was still low. So we've moved to cities. This is part of what kept our population sizes low because disease was more common and more concentrated. And that lack of knowledge about environmental impacts, suddenly we began to increasingly impact the environment, suddenly. So we talked about this Fertile Crescent back in Lecture 3. So this is actually kind of a rerun of that. You can see that this is the area known as the Fertile Crescent, goes from the Upper Nile, stretches all the way here to the Tigris and Euphrates, back through Mesopotamia, if you will, Turkey. They even, I think they count Crete as a part of this Fertile Crescent idea. Cradle civilization, at least one of these birthplaces of agriculture, urbanization, writing, trade, and science. Usually fertile region, encouraged the cultivation of grains. We talked about this, brewing of beer, domestication of animals. Development began about 12,000 years ago. There's a succession of rulers, wars, conquest. However, by 2,600 years ago, the cities were largely in ruins. Rampant overuse of the land and urbanization had gone on. Today, thanks to extensive damming, channelization, and rivers, this region remains largely barren. That's just one of those things. Industrial societies. So we've moved from agricultural societies, 18th and 19th centuries, to the present. This is our image of an industrial society where you have these smokestacks, train lines, water. I can't tell whether it's polluted or not because this is more like a lithograph. But increasingly we became a lot more mechanized. We had new technology. We had better sanitation. We were starting to figure out that sanitation was necessary. Our population began to grow rapidly. This is from the time about 1750. Our population actually crossed the 1 billion people threshold in 1805, I think was the number. We saw, and this picture sort of illustrates that rapid environmental deterioration. And these industries rely on new technologies, new sources of energy like coal, which we hadn't been using before, and even more new materials. We're learning to mine things out of the ground and then combine them together and make new things. And a new labor force. First, we had to have a lot more people to operate these factories. Recently, however, because of technological advances, because of robotics, if you will, even, the numbers have actually begun to decrease. We don't have as many people, if you will, working in the labor force because we don't need them. And we've seen a variety of blames placed on this, but actually it's modern mechanization that's done this. And biotechnology is becoming increasingly important to this. So industrialization, a little more colorful image of the pollution that's coming out of those smokestacks. We basically shifted from this manual labor, from plow and horse and the forge and those sorts of things, manually machining things, to energy intensive machine production. This energy intensiveness, lots of smokestacks. Likely this is they're horse-drawn train down there. I don't know how that works, but there's it's a fairly stark image. You see a lot of smoke coming out of it. It's an obvious force affecting the environment. Success of industrialization. Industry is highly exploitative. It's focused on maximizing that material output, so you get more stuff for your input. Humans are more subject to infectious disease and new industrial age diseases because there are more of us packed closer together. And industrial age diseases are things like the diseases you get from mining or from having to breathe this smoky air. We have rising affluence and rising consumption, and that pollution and environmental destruction were part of the result. So we talked about the average earlier, the average number of the average age at which a caveman died. So looking at this, infant mortality plays a big role in lower than average death age for hunter-gatherers. So 200,000 BC, this is once again the average. The average life expectancy was 15 years, but that wasn't really, that's the average age of death, 15 years. 20 years, approximately, in 20,000 BC. 2,000 years ago, 28 years. 1800, 35 years. And in 2011, we considered that 67 years to be the average life expectancy. Well, we've greatly reduced. Most of this has been due to a decrease in infant mortality. No population can grow indefinitely, so how long can we've seen this fellow before, this is Thomas Malthus, we affect, to some extent, some degree, 83% of the Earth's land surface. We impact that, we plow it up, or whatever we're doing with it. Malthus hypothesized that human populations, and I've said this before, grow exponentially, while food supplies only increase at a linear rate. But so far, we've been able to keep our food supplies going at a fast enough rate that we're still feeding ourselves. We keep changing things. Resource use in the U.S. is much greater than that in developing countries, and we're going to get to that idea of the ecological footprint. Average Americans is 9.5 times that of the average Indian. So how long can we continue to grow? This is an idea of natural capital degradation. So it's a problem that we have too many people, or that we're consuming too much. I don't know why I keep blanking out like that. Natural capital, reducing biodiversity is one of the things that we're doing. We're increasing the use of, says net primary productivity, greatly increasing the amount of crops we grow. We're increasing genetic resistance in all kinds of pest species, weeds and things like that. We are eliminating a lot of natural predators. We've killed off a lot of wolves. We are introducing some harmful species into the natural world. We've talked about those, talked about water hyacinths, and there are several others. I don't know why that went away. We're using some renewable resources faster than they can be replenished and disrupting those natural chemical cycling energy flow. So, back to the idea of ecological footprints. Today's level of consumption, we need 1.3 planet Earths to sustain our current per capita use of renewable resources. By 2050, estimates are that it will take two planet Earths. I wasn't done with that slide yet. It will take 2 planet Earths to sustain human populations. 5 Earths if everyone uses resources at the same rate as the United States. I just wanted to go on. Alright. Ecological footprint idea again. Seen this before. United States uses 25% of the global biological capacity. European Union 19%. China 18%. India only 7.8%. When you compare that, though, over here to India, to the actual ecological footprint in terms of hectares per person, it's 0.8. Because they have such a large population, they use a very small amount of global capacity. Here in the United States, we use 9.7 hectares per person. That's our ecological footprint. All right. This footprint needs to be balanced in the analysis by the capacity of the Earth to recover from our overuse, that biocapacity. So, population resources and pollution modeling. Human populations acquire and use resources, and so doing we negatively impact air, water, and soil. But we have to have those things. What sort of pollutants do we have? We can have pollutants that are biodegradable, such as organic wastes of various types, or non-biodegradable, like heavy metals and things like that, that aren't going to be degraded in the environment. We see that we have enhanced both negative feedback loops and positive feedback loops. The positive feedback loops, we've greatly increased the amount of nutrients, the amount of growth of noxious weeds and algae in lakes. And a lot of that is because of this excess nutrients that we kept putting on there. That's a positive impact loop. We've manipulated the environment tremendously to do that. So let's look at what a sustainable actually means in this case. The next step, we've gone through the hunter-gatherer, the agricultural, and the industrial revolution, and kind of calling here, at least in this chapter, for a thing called the sustainable revolution, or sustainability revolution might be a better way of putting it. A lot of changes are underway, starting to restructure human systems for sustainability. That idea of going back to eating paleo is another one that fits into that. I'm not sure how sustainable that is, but anyway. So, there's a balance between supply and demand. We have this input supply rate, output consumption rate. We look at environmental sustainability. It's the ability to sustain the exploitation of natural capital to meet our needs. We look in terms of agriculture, forestry, fisheries, I could say mining. We could go to all kinds of things that we're exploiting to meet our needs. So, this balance between supply and demand. This is the natural capital image. Come back here, I'm not done with you yet. There we go. Natural capital image. Environmental change and societal change impact natural capital. And human well-being depends upon our ability to actually live off the land. The soil, the water, the carbon, all those things that go into function and service of human beings. So natural capital is that range of natural resources provided by ecosystems. So air, water, soil. We talked about that. Environmental sustainability is based on the concept of sustainable yield. Sustainable yield. Very important concept, one that we don't always understand. We're going to talk about it a little bit. Same image again. So, sustainable resource use is constrained by this supply of those resources and the demand for them, and how fast can they be replenished. So the rate at which resources are being supplied and the rate at which resources are being consumed, being used, that's what constrains things. So that balance between supply and demand, this is an example from the Aral Sea. Aral Sea is actually almost dried up now. It's in Central Asia. Sustainable exploitation, that's my definition I was looking for. Sustainable exploitation is when the rate at which resources are used is less than the rate at which the resource is being renewed. So use it slower than you're able to renew it, and it'll renew itself. That's sustainability. So in this case, this is the Aral Sea. It's between Kazakhstan and Uzbekistan. Water is, as we know, a renewable resource. In this case, it's not being renewed. Inflowing rivers are diverted to provide irrigation for crops. Starting in, after World War II is when they started a lot of this in the Soviet Union. Leftover salt, which is where those brown areas are, has contaminated thousands of square miles of farmland, not just the former bottom of the sea, bottom of this Aral Sea, but many miles inland from it. Current rate, the Aral Sea will disappear completely by 2020. So that rate of resources decline is a function of how fast we're using it. Whether it's mineral resources or those natural gas, coal, and oil resources that are non-renewable because it takes millions of years to renew them, so to speak. Those are all considered non-renewable resources. So the Aral Sea actually is being renewed to a small extent. Only a fraction of the sea is recovering. We've gotten back, they, I believe this is Kazakhstan, has gotten back about 8% of the volume that was present in 1950. We haven't gotten it back, that's all that's left actually. But you can see that this area has actually increased. The North Aral Sea has increased over that last 15 years, largely because this dam was put in place to prevent this water from flowing out. But all of this area here is become desert. That North Aral Sea, only some 8% of the water volume from the late 1950s remains. Moving in the right direction. Will we ever get back to what was present in 1957? Unless we drastically reduce the amount of water use. It's amazing we could have cut off that much water. So, worldometers, worldinfopopulation.com. I will update the number at the end of class, and I'll put that on the PDF file. So you'll have to look at the PDF to get the answer to this next question. So what's the world's human population at the end of class today? You can bet it's going to be 7,543,000,000, probably 15,000 and something. But I'll write that number in when I look it up. Human biological evolution, we talked about that. What makes us so good at this growth thing anyway? Human cultural evolution. Through hunter-gatherers, agricultural societies, and industrial societies. And those advanced industrial societies, which we've come to recently. Looking briefly at a population, resource, and pollution model, and human-generated pollutants. Those feedback loops that we really have greatly enhanced. And the next step, which is a sustainable society. Now don't go away. This is something you'll want to pay attention to. This is the introduction to the main essay for this course, the environmental problems essay. And this certainly counts as an environmental problem. That is the Niger River Delta, and those black spots there are actually oil that's washed ashore. It is a very desperate situation. You'll also find this is one of, actually this is the assignment for lecture number 8 in the Niger River Delta. So, library learning assignment, environmental problems and solutions essay. Question, regarding human impact to the environment, consider the impact, the cause of that impact, what parts of the environment are being threatened, and what solutions being pursued to restore this part of the environment. And if nothing's being done, propose a solution. Or if you don't like that solution, propose a better one, like for the RLC. That's a great one. As it is relevant, threats to indigenous populations, human populations, should be considered, as well as threats to other species, other habitats, or other natural resources. This environmental problem can be either local, as in here in Central Florida, regional, as in anywhere in the southeastern United States, or global, anywhere on the planet. So find one, though. Don't define environmental problem, because you don't have that much space. You don't have a lot of working space here. So here we go, length and content. 500 to 700 words. That's not an awful lot. Please don't go over 700 words. I think you can do it in that length of time. Essay should introduce the impact, discuss the cause, primary threat to the environment, and current actions to solve or contain that problem. And then the impacts. Are they physical, chemical, abiotic factors, or are they related more to habitat destruction? The fact that we have introduced Melaleuca trees or things like that. We've gotten rid of predators like the wolves. Come back here, I'm not done with that. Or we've caused the spread of pathogens. Those sorts of factors, abiotic or biotic factors. So, 2 parts of this assignment, draft and the final. Up to 25% of your total final grade. This is a very important point. I'm going to emphasize it. To receive full credit for the draft, you only have to turn it in to the Dropbox by the deadline. And the deadline is coming up in the next bullet. Oh, essay length, we already got that. Use 5 citable references. Wikipedia is not considered to be a valid reference for this assignment. You can use Wikipedia to get ideas of where to go for a valid reference, but do not use it as an actual reference. All these essays are run through originality check. You turn it into the Dropbox D2L, but that's linked to turnitin.com, plagiarism checking service. And my comments on your draft will reflect any issues identified by turnitin.com as I find them relevant. One word about turnitin.com, I could say a lot, but I take it with a grain of salt and I actually look at what you wrote, because there's sometimes when turnitin.com is incorrect, and sometimes it doesn't emphasize the things it should. So anyway, it's a starting point for me, and I'll make those things available to you. So again, back up to the draft, you only have to turn it into the Dropbox by the deadline. On all the draft doesn't have to have 500 words in it. The draft only has to have enough for me to be able to say, oh, this is what you're talking about. A sentence or two will be sufficient for you to get full credit. But the more you give me, the more you write, the more comments, the more guidance I can give you back. Okay. File containing the grading rubric and online resources. Plagiarism are now available in the Environmental Problems Essay Content page, and please use Microsoft Word if at all possible. There are other forums. I'll have a note posted as to what the acceptable extensions are. I believe certainly a Word document, a PDF document, a text document, a rich text format document. Those are the standard ones that are acceptable to turnitin.com, because I really don't want to have to convert these things. It becomes old. First important date, and the draft for full credit, 100 points, Friday, November 4th at 7 p.m. That's coming up fast, isn't it? Well, we're not to October yet, so hop on this, doggy. To receive full credit for the draft, you only have to turn it into the Dropbox by the deadline. To receive, I say this again, full credit for the draft. Questions about that? In other words, I'm not going to give you a grade on the draft except when you turn it in. So, you can turn in late drafts, because this always happens. Oh, I forgot. Well, here specifically is what I expect you to understand. It's decline after you turn it. If you turn it in late, it declines in value by 25% per day. So 100 points if you turn it in by 7 p.m. On November 4th, 50 points after 7 p.m. on November 5th, You only get 25 points after 7 p.m. on November the 6th, and you will get a 0 if you turned in after 7 a.m. on the 7th of November. Now, I will still give you comments back if you turn in after that, but you will not receive any points for the draft. Drafts be graded, copy returned to you electronically by November 21st. A lot sooner. I really hope to get those done a lot sooner because I have other things to do that week with those suggested corrections, and so do you. You then have until December the 2nd, 7 p.m. to make corrections and submit them to the final essay drop box. I think that covers it, but if you have questions, you know how to reach me. Send me an email, give me a call, send me a text, all those things. Look forward to working with you on these. And these are the references for this particular lecture. There are also some noted in the previous slides. And I believe I have to go and find what the current population of the Earth is in terms of human beings. So, if you'll excuse me, I'll get on that right now.